Yeah, so in this video what we are going to do is we are going to talk about decision tables. And the reason why we moved to this, because previously we saw that in case of your boundary value analysis, the possibility was that we were able to uncover the defects at the corners, right, at the boundary locations, and still the number of cases were on the higher side. And for that sake we moved to equivalence class partitioning, where we said, or equivalence class testing, where we said that we can reduce the number of test cases, and now the number of equivalent classes will be equal to number of test cases. So we were able to reduce these test cases drastically. But the problem arises when your inputs, when we have like number of inputs, and these inputs are interrelated in some sense, right? In that case your boundary value analysis, because let's say there are like 5 inputs and 5 inputs are interdependent, so finding of the boundary values will be difficult from the set of 3, because for each value I have to look for some boundary value analysis, and when these values are interdependent, then the problem becomes much more tougher. So basically your decision table, which we are going to focus, is one of the widely used case design technique, and especially for your black box testing technique we will be using it, right, because the entire discussion revolves around your black box testing techniques. So it would be revolving around the black box testing only, right? So this approach is basically in some sense comparatively a better and a systematic approach, where what we do is like we take various input combinations and then we tabulate based on the input combination how the system is going to behave. We try to tabulate it, and that's why it is also known as your cause effect table. So the table is known as cause effect table. So this technique is used to pick the test cases in a systematic manner. This would help us in saving the testing time. It would definitely give us good coverage, and we'll be able to uncover the defects if there are. So this technique is basically related to the correct combination of inputs and then determining the result of various combinations of those inputs. And in order to design the test cases by the decision table technique, what we do is we consider the conditions as input and actions as output. That would be clearer, the picture will be much more clearer with the examples which we are going to take. So when we talk about decision tables, it is like a precise yet compact way to model the complicated logic, right? So the logic is modeled very well in this, and then we have like associate conditions with the actions to perform, and can associate many independent conditions with several actions in an elegant way. So as we previously discussed, that this is something which is very much systematic approach. So a program's behavior is characterized by several decision variables, and each decision variable specifies a Boolean condition, right? What Boolean condition is, I think I don't need to throw some light on it, and combinations of these decision variables lead to different scenarios. Each scenario occupies a row in the decision table, and the row has the expected result, and one representative data point from each scenario needs to be tested. So your in your boundary value analysis and in your equivalence partitioning methods, these things were not considering the combinations of input conditions. these things consider each input separately, right? As far as your BVA is concerned, or equivalence class partitioning or equivalence class testing is concerned, these things consider each input separately. So it's like the combinations are not considered, and there may be some critical behaviors to be tested when some combinations of the input conditions are considered. For example, let's say I have 4 sides and I have to identify that whether these sides are of a square or a rectangle, right? So in that case, my output depends on the kind of input we have, and even these inputs are interdependent as well. Let's take one example. So what we have is, okay, before taking the example, let's see the rough layout. So what we have is, on top of it we have like conditions, these conditions, and then we have these rules. So where we have to identify whether true or it is false, holding true or false, or even simply write zeros and ones, where then based on these conditions I have several outcomes, right? And I have to identify those outcomes, and from this I'll be ultimately forming the test case data table, right? So some of the applications of these decision tables can be in your business analysis, in your programming, in your hardware design and testing as well, where our focus is. So what we are going to do is, we are going to talk we are going to take another step in decision table, and then we'll see some basic examples, and then we'll take a complicated example as well in our discussion. So the first step is that I need to identify the decision variables, and afterwards I need to identify the possible values of each of the decision variables. Then further I need to enumerate the combinations of the allowed values of each of the variables. I need to identify the cases. Then further I need to list out the actions or expected results, and the last step is, based on this step I'll be forming a table. Now let's take some simple example, right? So basically I took this example from Microsoft Office 2007. So what we see is that in case of this checkbox, right, and this continue button, I have to rely on this. If this holds true, then only this will hold true. So for this scenario, what we can do is that I can draw the table where I can have like condition. It will be a comparatively smaller table. On this side I have condition, on this side I have outcome, and as we saw previously, on these sides we have the rules. So first is like checkbox. When checkbox is checked, that means it is true, my continue button becomes operational, and when it is false, my continue button is not operational, right? So that's how we are forming a decision table for this. We have certain conditions, right, whether it is on or off, and based on that this becomes on or off, right? So comparatively a very simple example we took. So let's take a step ahead, and yeah, so what I did, I took the screenshot of the WAM server installation. What we see is, this time I have like 2 inputs, and based on this I see 3 outputs, and what I see is that these things are always on, but this is not on always. This depends on the input from this. In this case we have like conditions will be these 2, I accept, I do not accept, right? And the outcome is, my outcome is back, next and cancel. So I have added back, next and cancel. When I accept, right, this is false and this is true. In that case, right, sorry. So in this case, initially in the rule 1, I am accepting this is false and I do not, this is true. So this becomes inactive. Both the things are active in this scenario. When I accept the agreement, which is true, and I do not accept, this is false. So in that case, all these things becomes true, right? This is the scenario. Sorry. This is the scenario. Now let's take another example. This is comparatively complicated, not that complicated as such. So I have to draw the decision table with side A, B, C as possibilities, and I have to identify whether these sides A, B and C are not forming any triangle, or it's the scalene triangle, that means all the sides are unequal. It is forming isosceles triangle, that means two sides are equal, or it is forming an equilateral triangle, that means all these sides are equal. So in this case what we have is, we will be having like these many rules: 1 2 3 4 5 6 7 8 9 10 11. So the first condition will be like two sides, sum of two sides greater than third, and the second will be like the next two sides greater than third, and the last one will be the next two sides greater than the last one. And then in that case, if suppose this holds false, then what we have is that I'll not be able to form the triangle. Let's say in the second case, this is true, this is false, once again I will not be able to form the triangle. And if suppose in this case this is true, this is true, this is false, then also I will not be able to form a triangle. Now in rest of the cases, if these three things holds true, that means I'll be having some triangle, right? These things are true. I'll be having a triangle, but not sure what kind of triangle we'll have. So the next thing will be, we'll be comparing this. If this holds true, this holds true, this holds true, that means A equals to B, B equals to 1, and C equals to A. Obviously I'll have an equilateral triangle as an outcome. Similarly, then the next combinations will be like these two are true, but this is false. So this is something which is impossible, right? A equals to B is there, B equals to C is there, and C is equals to A is not there, so not possible. Similarly, I'll be able to identify this thing which is not possible and this thing which is not possible. Now I'm left with the cases where this holds true, that means A equals to B, but B and C and A are not equal, right? Isosceles, similarly I'll find two more conditions for isosceles, and when all the things will be false, I'll get the scalene triangle, that means none of the sides are equal, right? That's how I'm able to identify the decision table, and afterwards we'll design the test case design using the decision table. So I'll have these test IDs which were there, right? These things, and I have like inputs. I've given some random values, right? Which will be actually firing those values, right? So what I got, either not a triangle, equilateral, or let's say, right, isosceles, impossible, scalene, right? So these things we'll be considering. Now the question arises, when to use decision table. So the best thing is when there is lot amount of decision making, then I'll be using this decision table. Then we have like, there are important logical relationships among input values, and there are like cause and effect relationships between the input and output. In that case, we'll go ahead with these things, right? Now then we have like, if suppose we are talking about cause and effect relationship, so your cause and effect relationship is like, when I have an event A, then another event B is more likely to happen, right? The next technique is your compatibility testing. So what we have is like, to test the effect of the effect on the product due to change in the infrastructure, we go for compatibility testing, right? Infrastructure can be your hardware infrastructure, your software infrastructure, your networking infrastructure. If there is any change, then we go ahead with this. So this ensures the correct working of the product on different infrastructure components. So my infrastructure includes my processor, the kind of machine I have, whether 32-bit or 64-bit, the memory available, the operating system, my web server, application server or network server, the database servers or the compilers, linkers, loaders and whatnot. The next thing we have is UDT, right, which stands for user documentation testing. So what we do is that in order to check if what is stated in the document is available in the product, we go for UDT. And to check if what is there in the product is available in the document. So both the things we are matching. Then we have like these documents will be including the user guides, the installation guide, setup guides, readme files, software release notes, and the online help. So basically my UDT ensures the documentation matches the product or not. Some of the benefits of user documentation testing includes like user documentation testing aids in highlighting the problems that have been overlooked during the reviews. The high quality user documentation ensures the consistency of the documentation and the product, thus further minimizing the possible defects reported by the customers. And this results in less difficult support calls and further contributes to better customer satisfaction and better morale of supporting staff. The new programmers and testers who join a project group can use the documentation to learn the external functionality of the product. Customers need less training and can proceed more quickly to advanced training and the product usage, and further it reduces the training cost for the customers as well, because if I have my documentation is thorough, then I'm able to reduce this particular cost as well. Now the next one is the domain testing. From the title itself you might have got some idea that it is related to the business verticals and horizontals. So testing the product based on the domain knowledge is nothing but the domain testing, and performed by the test engineers with the knowledge of your business domain. So domain testing is the ability to design and execute the test cases that relate to the people who will buy and use the software. So if suppose a particular application is for loan management, so I need to have someone who has the idea about the domain, right? So that would be the best person in order to test the product. So I need to hire the testers from domains such as like banking, insurance, etc. And then I can train them in software to reduce the effort and time. Next is your error guessing, right? So what we do is we do it when all the methods fail, and basically since it's error guessing, so it's intuition based testing which uses bug history. So expert testers can easily smell out errors as compared to a novice tester, and that's why we need to have the experienced person for this. Now error guessing like system for calculating the roots of a quadratic equation when we can have like when equals to 0, when all inputs are negative, when input list is empty. This gives us a basic idea that okay, how we can guess an error for a particular product. So now let's talk about the pros and cons of black box testing. First of all, it's easy to use because I don't need to look into the code part. I have to only deal with executables, and then we have like quicker test case development, and even the third party vendor can test it. And of course it's comparatively similar because as till the time I don't dissect or bisect the piece of code, it's simpler. The drawbacks are like I need to maintain the script, and since if suppose I don't have the tools, then definitely I have to rely on these scripts only, and this lacks the thoroughness as well, right? It lacks the thoroughness. Now this is the reference from which I took the set of slides for the discussions. So this was all from my side for this particular discussion.